Alright, so the next thing it asks us to do is to figure out how long the ball is in the air before it hits the ground. So it's wanting us to find the total time that the ball is in the air. So one thing that we can do now is, instead of considering the first half of the motion, we can consider the second half of the motion. So if we consider the ball being at its max height to be the initial condition, then our initial velocity is going to be 0, and our initial position is going to be 20 meters. We don't know what the velocity is going to be when it hits the ground, but we do know that the final position is going to be 0 meters, right? Because we're considering our positions to be locations on a number line. In this situation, the number line on the y-axis. We also have that the acceleration is going to be negative 9.81 meters per second squared, and we want to find the time that it takes. So what I want to do now is I want to figure out what kinematic equation I can use. I want to find a kinematic equation that involves time, so it has to have the variable for time. So right away I can see that equation 4 does not contain the variable for time, so I'm not going to be able to use that. The next thing I want to do is I want to get rid of any equations that require information I don't know. So for example, equation 1 is going to require a final velocity because of that average velocity, and it's also going to require time. That's two unknowns, so I won't be able to solve that equation. The same thing goes for equation 2. I don't have that final velocity, and I'm solving for time. That's two unknowns with one equation. I won't be able to solve that. But I can use equation 3 here. So equation 3 is our final position is equal to our initial position plus the initial velocity times time plus 1/2 acceleration time squared. Now, I always tell you, do not plug in numbers until you do all of the algebra. There is one situation where I encourage you to plug in numbers before you do algebra, and that's whenever you have zeros in some of your variables. This makes it easier to simplify the equation. So for example, my final position is 0, and also my initial velocity is 0. That's going to really simplify this equation for me, and it's also going to make it so that I don't have to do the quadratic, right? Because now we have only the initial position plus 1/2 acceleration time squared. I can now rearrange this to solve for t. So I'm going to put my term that has t on the left-hand side, and that will be equal to negative y initial. I'm then going to multiply both sides times 2 and divide both sides by acceleration. This will give me time squared is equal to negative 2 y initial divided by the acceleration. The next thing that I need to do is I need to remember whenever I take the square root, it has to be plus or minus the square root, right? Because the positive or the negative solution in most situations is a valid answer, right? Either one could be possible. Except for with time, it's not possible for us to have a negative time, so it's easy for us to determine that this should be the positive. So I'm going to go ahead and plug in my numbers, and I will get that the time it takes for the second half of the motion, right, the time it takes for the ball to fall to the ground is going to be 2.02 seconds. But it asks us how long the ball is in the air before it hits the ground. So if I consider the ball being in the air, I need to consider it from the moment that it left my person's hand. So I need to add my 2.02 seconds to the time it takes for the ball to reach maximum height. This means that my total time that the ball is in the air is going to be 4.06 seconds. Now some of you are probably thinking, well, if there's no other forces, right, if there's nothing acting on this ball, I toss it up, it goes a certain amount into the air, then it turns around, it comes back down, the only thing acting on it is gravity. Shouldn't that time be the same? Yes, ideally the times should be the same. So why are these different? Why do I have 2.04 seconds for the first half and 2.02 seconds for the second half. In all honesty, these are likely rounding errors, and I would consider them negligible. We're just going to ignore that. They're just rounding errors.